Filters are very useful electronic components. A filter allows a range of frequencies to come through and prevents other frequencies from coming through. There are three types of filters which are commonly used. One is called a low pass filter. This allows all frequencies up to a maximum value to come out without any decrease in the amplitude. All frequencies above the maximum are not allowed to come through. The other filter is a high pass filter. This allows all frequencies above a minimum value to come through. It cuts off all frequencies below the minimum value. The third one is called a bandpass filter. It allows all frequencies between two values f1 and f2 to come through, stops frequencies less than f1 or greater than f2 from coming through. We can realize these three filters approximately using combinations of resistances and capacitors. These are called passive filters because the components we use are passive components. You can also make active filters using op-amps. Here I have a box in which I have a low pass filter on the right side. I have a high pass filter on the left side, and by connecting the two I can realize a band pass filter. So all three filters can be realized here. In the low pass filter I have connected a resistance between the red and green terminals and a capacitance between the green and yellow terminals. So if I apply a AC voltage here, the impedance of the capacitance will be high at low frequencies, whereas the resistance will not change with frequency. So this will act like a voltage divider, and when the impedance of the capacitor is high, almost all the applied voltage will come between the yellow and the green terminals, that is across the capacitor. So for low frequencies the output will be almost 100%. But when you go to high frequencies, the impedance of the capacitor comes down, and therefore the voltage across the resistance keeps increasing as you increase the frequency, and for very high frequencies the voltage drop across the resistance is almost the total voltage you apply. Voltage across the capacitance will be low. So the input is the voltage between the red and green terminals. Output is the voltage between the yellow and green terminals. To measure the characteristic of the low pass filter, I connect the output of a signal generator between the red and green terminals. So this is the input voltage, which is about 1.1 volt, and this is the output, which is 1.09. So transmission is almost 100% when the frequency is about 170 Hertz. I now make the frequency 1.6 kilohertz. Then you find that the input is about 1.02, output is 0.96. It is still 96%. But I increase the frequency further and go to 7.56 kilohertz. Output is 0.29 and input is 0.66. Therefore, only 30% of the voltage comes through. So as you go to high frequencies, transmission becomes less. At low frequencies, transmission is 100%. This is a low pass filter. If you now connect the signal generator between these two terminals, this is a high pass filter. Here between the red and yellow terminal, I have a capacitance. Between the yellow and green, I have a resistance. At low frequencies, the impedance of the capacitance is high, so most of the voltage drops across the capacitance. Only a small voltage appears across the resistance. So the voltage across the resistance is the output, voltage across the red and green is the input. So the output is small at low frequencies. But when I go to high frequencies, the impedance of the capacitance becomes small compared to the resistance. So most of the voltage that you apply appears across the resistance and you get a high transmission. So you connect the signal generator between the red and green, change the frequency, measure the total voltage and voltage across the yellow and green terminal, show that the transmission is low at low frequencies and becomes 1 at high frequencies. To get a bandpass filter, you must connect the output of the low pass to the input of the high pass. You should also connect these two ground terminals together. Now you connect a signal generator to the input of the low pass. Now this low pass filter will allow all frequencies up to, let us say, 5 kHz, and it will cut off frequencies above 5 kHz. This high pass filter will allow all frequencies above 1 kHz, cut off all frequencies below 1 kHz. So when you have this combination, the two together will allow frequencies between 1 and 5 kHz to come through. Frequencies below 1 kHz will be obstructed by the high pass filter. Frequencies above 5 kHz will be obstructed by the low pass filter. So you find transmission is a maximum over a band of frequencies. So here you measure the input voltage between the red and green on the low pass side and the output voltage between the yellow and green on the high pass side. The green is common to both, they are connected together. So this will give you the input voltage, this will give you the output voltage. And you can see at 6 kHz the output is small. Now as I reduce the frequency, input is about 0.7475 and the output is 0.02. Now I will reduce the frequency, so I will change the frequency and you will see how the output will change. I will go to very low frequencies. Frequency is 250 Hz, output is only 0.15 volt. As I increase the frequency, the output will increase, and then I will go, this goes up to nearly 1 kHz. Then I will go from 1 kHz up. Okay, this is 1 kHz. I will increase from 1 kHz. It keeps going up and then it will start decreasing. It starts decreasing. So it will transmit frequencies in a range. It's not a sharp cutoff, but in a range of frequencies, let us say from 1 kilohertz to about 3 kilohertz. So this is a bandpass filter.